You also need to be able to identify the rational form of different numbers presented in different formats. Okay, so the first is, let's take a look at a terminating decimal. All right, so if you have a decimal, no matter how many, let's see, we'll put 3 decimals. Okay. Anytime you're looking to write or find the rational form of a terminating decimal, you're simply going to follow these steps or rules. Okay, step 1, you're going to write all the digits. You're going to disregard the decimal, and you're just going to write the digits. So here my digits are 8, 4, and 2. And then what you're going to do is divide by 10 to the power of n, where n is the number of digits that fall after the decimal. Okay, so here we're going to take this, we're going to divide by 10 divided by, and then how many digits fall after the decimal? 3. This gives you the place value of that last digit. Okay, so that's the other way to think of it. You could divide by the place value of the last digit, but you have 842 thousandths. That's what it represents. And so that is the fraction. That's your rational form. Okay, so even right here, you have a rational form. You have the number written as the quotient of 2 integers, 842 over 1,000. Now, you do need to simplify this completely. So if you took 842 and divided by 1,000, you would get the simplified form of 421 over 500. Can't be simplified any further than that. So that is the rational form of that particular terminating decimal. And this process would be used anytime you're dealing with a decimal that has a specific end to it. Right? And so this is why any terminating decimal is still considered a rational number. Questions on that process? All right, let's look at the second case, which is the non-terminating but repeating decimals. All right, what I'm going to do is I'm going to talk through the steps for this by using an example that should be familiar to you. And that example is 0.33 continuing. Okay, because what is the rational form of 0.33 continuing? 1/3, right? So everybody's familiar with that. So let's show how we can find this rational form. All right, anytime we're dealing with these repeating but non-terminating decimals, first of all, there's a couple ways that you might see this expressed. You might see it expressed as the bar over it. So 0.33, it might just be the 0.3. Again, whatever the bar covers is the digits that repeat. So even though I put 2 digits here with the bar on them, how many digits are actually being repeated here? Just 1, right? Just the 3. You might also see it written in the form of a ... Okay, so once a pattern's established and you see ... that represents that pattern's going to continue. So here the pattern is just a repeating single digit. So 3, 3, so that means ... represents that pattern of 3 repeating will continue. All right, so let's take a look at the methods for converting this repeating decimal into a rational form. Okay, the first step is to set x equal to original number. And so basically all you need to do is set your original number equal to x. You're creating an equation here. Okay, once you create your equation, what you're going to do is you're going to find How many digits repeat? Okay, and that's going to be your n value. Okay, so right here, what I'm going to look at is how many digits repeat in 0.333 continuing? It's one single digit. Just the digit 3 is repeating infinitely. Okay, so what you're going to do with that number is you're going to multiply both sides of equation from step 1 by 10 to the power of n. Okay, so what I'm going to do is I'm going to take 10 to the power of n, in this case 1, and I'm multiplying both sides of this equation by that number. So 10 to the first is 10. 10 times x gives me 10x. And 10 times 0.33 repeating moves my decimal place 1 over. But then the 0.33, or the 3's continue, so I'm going to mark that with either the line or the dot, dot, dot. And you should always, in this step here, the repeating numbers should always be the same. Okay, so here I have 0.3 repeating, 0.3 repeating. So in both equations 1 and 2, or the equations 1 and then this equation in step 3, the repeating digits have to be the exact same. Because what you're then going to do is you're going to subtract the equation from step 1 from the equation in step 3. And that's going to give you a new equation to work with. So when I subtract that, I get 10x minus 1x, which is 9x. And here, because of this, repeating digits are aligned the exact same. When I subtract those, the repeating part, all the decimal parts should cancel completely. So I'm left with 3 minus 0, which is 3. And so your final step is to solve for x. That is your rational form. And just a note that you may need to simplify the fraction. And when you write your answer, it does need to be in the simplest form. So here, when I'm solving for x, I'm going to divide both sides by 9. I get x is equal to 9/3 simplifies into, 3/9 simplifies into 1/3. And so I get my rational form. So the rational form of 0.3 continuing is 1/3.